Any the textbook? So up to 1.19 we discussed, yes or no? Next 1.0. A conducting sphere of radius. Sphere radius equals to 10 centimeters equals to 10 power minus 1 meter. Come in, sir. Has an unknown charge. Unknown charge. Q means unknown. Okay. If the electric field 20 centimeters from the center of the sphere is E equals to 1.5 into 10 cube Newton per coulomb. Points radially inverse. What is the net charge on the sphere? What is the net charge on the sphere? This is the sphere, yes or no? This is the sphere. Okay. Sphere radius is 10 centimeters. Sphere radius is 10 centimeters. And the electric field 20 centimeters from the sphere. Electric field from the 20 centimeter from the sphere is E equals to 1.5 into 10 cube Newton per coulomb. Points radially inverse. Radially inverse. Electric field will be radially inverse. The electric field radially inverse means here charge is positive charge or negative charge. The electric field line starts from the positive charge coming ended the negative charge. So positive charge. You know the formula for sphere electric field E equals to electric field E equals to Q by Q by 1 by 4 pi epsilon naught Q by R square. Yes or no? This is only for the or not. 1 by 4. This is the outside. 20 centimeter means outside. Outside, what is the formula we have to use? 1 by 4 pi epsilon 2 by R square. So you have to find out Q charge Q equals to E into 4 pi epsilon naught into R square. Yes or no? So you have to find the net charge on the sphere. So E equals to 1.5 into 10 cube into 4 pi epsilon naught 8.85 into 10 power minus 12 coming into R square. What is the radius? R 20 centimeter. So no. 20 centimeter equals to 2 into 10 power minus 1. Yes or no? 20 by 100. 20 by 100 means 20 centimeter. How much you will get? 20 into 10 power minus 2 meter. Yes or no? So you will get 2 into 10 power minus 1 meter. Okay, so square 2 into 10 power minus 1 whole square. So that's equals to 1.5 into 10 cube into 4 into pi means 3.14. Tell me the answer. 3.14 pi. Pi value is what? 3.14 into epsilon naught. 8.85 into 10 power minus 12 into 4 into 10 power minus 2. Calculate that. Calculate the value. Inwards. That means outwards positive, inwards minus. Okay. Calculate that inwards. I want to complete this exercise. This counter exercise. If I get the last one of the examination, I will explain the concept. I will explain the entire concept for the okay, minus 6.67 into 10 power minus 12. How much you will get? Minus 9. Okay. So minus 6.7 nanocoulomb. Approximate value you will get. You approximately you take 9. Approximately you take 3. Okay, you will get the answer. Huh? You will get minus 6.67 nanocoulomb. Electric field inwards. So minus outwards positive. We can go for next problem. 1.21. Uniformly charged conducting sphere of diameter. Diameter D equals to 2.4 meter. So R equals to D by 2 equals to 1.2 meter. And surface charge density. Surface charge density means what is the formula? Surface charge density sigma equals to Q by A. Charge by area of the enclosed surface. Charge by area. Area. So find the charge. What is given? Charge density sigma equals to 80 microcoulomb per meter square. Find the charge. Sigma equals to Q by A. So Q equals to sigma into A. So sigma equals to 80 into 10 power minus 6. The area, what is the formula? What is the formula for sphere area? 4 pi r square. 4 pi r square. 4 pi r square. Since area equals to 4 pi r square. So 80 into 10 power minus 6 into 4 into 5 into r square 1.2 whole square. So you will get 8 into 10 power minus 5 into 4 into 3.14 into 1.44. 1.2 whole square. Silence. 1.4 whole square is not 1.44 or not? 1 whole square, 12 square, 144. So 1.2 whole square coming 1.44. Calculate. So Q equals to. Calculate that answer. Answer is correct. How much? 1.45 millicoulomb. 1.45 into 10 power minus 3 coulomb equals to 1.45 millicoulomb. 45. Okay. Next, what is the total electric flux leaving the surface of the sphere? Total electric flux. Formula is what? Pi equals to Q by epsilon naught. Q net charge by epsilon naught. So what is the Q? 1.45 into 10 power minus. Tell me, give the response. 1.45 into 10 power minus 3 by 8.85 into 10 power minus 12. Okay. So 1.45 I will give 145 by 885 into 10 power minus 3 plus 12 equals to 145 by 885 into 10 power 9. So 1450 into 10 power 8 by 885. Simplify this. 1.8 something you will get. Okay. 1.6. 1.6 into 10 power 8. Newton per coulomb meter square. Yes or no? Problem. Right on. Shall I go for next problem? Okay, right on. We have to apply the formulas to find the solutions for the numerical problem. First, given data we have to analyze, then apply that data to the any one of the formula in the chapter, then you have to find the answer. Application is very important. Next, 1.22. An infinite line charge produces a field 9 into 10 power 4 Newton per coulomb. An infinite line charge produces a field E equals to 9 into 10 power 4 Newton per coulomb at a distance of R equals to 2 centimeter equals to 2 into 10 power minus 2 meter. Calculate the linear charge density. Calculate the linear charge density. Linear charge density means what is the formula? Linear charge density. Sigma, yes or no? Sigma. What is the? This is infinite line charge. It's given infinite line charge. Infinite line charge. For the infinite line charge, what is the formula? Infinite line charge. E equals to, for infinite line charge, E equals to lambda by 2 pi epsilon naught R. Okay. So you have to find out the line charge density. Line charge density equals to lambda equals to E into 2 pi epsilon naught R. 2 pi epsilon naught into R. E is given 9 into 10 power 4 into 2 pi. Okay, 2 into pi 3.14 into epsilon naught 8.85 into 10 power minus 12 into R. What is the R value? 2 into 10 power minus 2 meter. Now find what is the value? Infinite line charge lambda by 2 by epsilon. Infinite charge sheet, what is the E? For infinite charge sheet, lambda by 2 epsilon naught. Yes or no? You have to remember the formulas. Otherwise, you are not able to solve the problem. What is the answer? Linear charge density. Lambda is called linear charge density. Linear charge density. N power minus 20. 0.99. 10 power 8 or minus 9. Minus 6. 6. Very good. 10 power minus 6 coulomb per meter. Linear charge density means what are units? For linear charge density coulomb per meter. Okay. So 0.1 into 10 power minus 6 coulomb per meter approximately equals to 0.1 micro coulomb per meter. Silent. Silent. Surface charge density. What is the formula? Surface charge density sigma equals to what is the formula? 2 by 8. Very good. Next, volume charge density rho equals to 2 by V. Okay. This is surface charge density. Surface charge density. This is the volume charge density. Volume charge density. Okay. We can use it in some other problems. Okay. Linear charge density and surface charge density and the volume charge density. Okay. Concentrate. Shall I go for next problem, last problem in this chapter? One point two three. Two large thin metal plates are parallel and close to each other. Okay, two metal plates. Two large thin metal plates are parallel and close to each other. On their interfaces, the plates have surface charge densities of opposite signs. Opposite signs. plus sigma minus sigma. Plus sigma minus sigma. Okay. Let's have the surface charge densities of the opposite signs of magnitude. Opposite signs of the magnitude. 17 into 10 power minus 22 coulomb per meter square. Okay. What is the electric field in the outer region of the first plate? Outer region. This is also outer region. Yes or no? Outer regions. Yes or no? 1 and 3 are the outer regions. And in the outer region of the second plate, and see between the plates. Between the plates. Between the plates. Now you have to find out the electric field. What is the E? Okay. This concept is very important. Okay, all of you listen about electric field due to the plus sigma. Electric field starts from positive charge or negative charge? Starts from the positive charge. And it ends at the negative charge. Towards the negative charge. Okay, towards the negative charge. So, here E plus sigma equals to in this direction or not? Okay, electric field start at due to the plus sigma in this direction or not? In this direction. So due to the minus sigma also in this direction or not? Okay, E minus sigma. E minus sigma. Okay, E minus sigma. So electric field. Okay. So next in the region, outer region, I am showing the first. Okay, numerical number 1. Okay. Due to the plus sigma, electric field will be towards the away from the plus sigma or towards the plus sigma? Away from the plus sigma. So, electric field E plus sigma in this direction. So, due to the minus sigma, electric field is towards or away? Towards the minus sigma. So, electric field will be E minus sigma. The E minus sigma. In the same way, in the third region, due to the plus sigma, away or not? Away from the plus sigma, this plate or not? Away from or not? Electric field away. So E plus sigma away from the plate. Okay. Due to this minus sigma towards the minus sigma or not? Okay. E plus sigma and minus sigma. E minus sigma. Okay. Now these both are equal in magnitude and opposite to each other. It will cancel or not? Cancel. So E net equals to 0. For this, E net equals to 0. E net equals to 0. So, region out of the outside of the plates, electric field is 0 or not? Electric field is 0. But in region, middle of the two plates, E net equals to E plus sigma plus E minus sigma. Okay. These plates are metal plates, parallel and too large. So what is the formula? What is the formula for E plus sigma and E minus sigma? Metal plates. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught equals to 2 sigma by 2 epsilon naught equals to sigma by epsilon naught. Okay. Sigma value what is given? Sigma equals to 17 into 10 power minus 22 by epsilon naught 8.85 into 10 power minus 12 approximately 2. So 2 into 10 power minus 22 plus 12 equals to 2 into 10 power minus 10 Newton per coulomb or not? Electric field Newton per coulomb. Write down. So this will come 0.9, approximately 0.9. 0.9. Okay, 8.17 by 8.85 is approximately how much it will come? You calculate this 17 by 8.85. Calculate 1.9 will come. Where is this? Where is this only? Calculate this sigma by epsilon naught. Sigma value by epsilon naught. Calculate and tell the answer. What is that? Any doubt? You have to calculate. I don't have the calculator. Numericals you have to calculate. Everything don't take correct. Right on the problems. These problems are very important. In the examination, CBSE board examination. Remember that always electric field is away from the positive plate and towards the negative plate. Okay. So I applied that concept here and I calculate the net electric field at the region 1, region 2 and the region. I don't see one that is. Don't see. 1.9 into 10 power minus 10 Newton per Coulomb. Correct answer. Approximately 2. I don't know. Select communicate. Shall I go for the concept? Entire concept can I revise? Okay. What is the first topic in the first chapter? Electric force. Yes or no? Before the electric force, I will explain what is the charge. Charge is a property of a material. Charge is a property of a material. How charge can be produced? Charge can be produced by the three methods. What are the three methods? Tell me. Reduction, conduction, friction. Very good. Charge can be produced by three ways. Charge can be produced by three ways. What are the three ways? One is friction. Second one is conduction. Third one is induction. You know friction. What is the friction? What is the conduction? What is the induction? You read that concept. What are the properties of charge? Additive, quantized, law of conservation of charge. What is meant by law of conservation of charge? Charge can either be created or be destroyed. Yes, charge can be transferred. Charge can be transferred. Charge can either be created or be destroyed. Okay. Next, I will go for the electric force. Before going to explain about the topic of the electric force, I will explain what is electrostatics. What is meant by electrostatics? Static means what? Reaction. So, electrostatics means charges are when the charges are stationary, that charges produces some effect. Okay. Or having some electrical properties. Okay. So electric force is between the 2 point charges. For example, you take Q1, Q2 are the 2 point charges. That 2 point charges are separated by a distance R. So if 2 point charges are separated by some distance R, electric force exists between the two charges or not. Electric force exists or not. Electric force exists between the 2 point. Okay, 2 point charges. Okay. So F is directly proportional to Q1, Q2. That means force between the 2 point charges is directly proportional to the product of the two charges. Next, F is inversely proportional to the square of the distance between the two charges. Okay. So F is directly proportional to the Q1 into Q2 by R square. Okay. So F equals to K into Q1 Q2 by R square. Okay, this is the equation number 1. So K equals to what is the value? 1 by 4 pi epsilon naught. That value will be 9 into 10 power 9. Okay, 9 into 10 power 9. What is the units? Newton meter square by Coulomb square. Okay, K value 9 into 10 power 9. So by using this formula, simple problems we can solve. But that is not important for us. We have to solve the problems by using the vector notation. Vector notation. What is that meaning, vector notation? Vector notation means here origin P. I am taking the point P and this point I am taking as the Q. Okay. Here x1, y1, z1. Here x2, y2, z2 are the Cartesian coordinates. Okay, Cartesian coordinates. So now force work on the charge Q2 due to the Q1. How can I put that? F21 bar. Yes or no? F21 bar. Force on the point charge Q2 due to the Q1. That is, I am indicating F21 bar. Okay, F21 bar. In the same way, the force on the point charge Q1 due to the Q2 is denoted with the F12 bar. F12 bar. Okay, F12 bar. The distance between this indicated by the R bar. Vector notation. R bar. You have to mention. So you know that if 2 points P equals to x1, y1, z1 and Q equals to x2, y2, z2. Okay. The distance between PQ bar equals to what? PQ bar. PQ bar equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay. So can I write in vector form? Vector form modulus of PQ bar. Okay. PQ bar equals to x2 minus x1 I ground plus y2 minus y1 j ground plus z2 minus z1 k ground. By using this, you have to solve the problem in the vector notation. That is a complicated topic. After your exam tomorrow, I will revise all the chapters. So then I will explain that concept. Okay. So next, electric field. What is the electric field? Electric field E bar equals to limit Q naught tends to 0. Okay. F by Q naught. Yes or not? Okay. F equals to 1 by 4 pi epsilon naught Q into Q naught by R square into Q naught. Q naught cancel. So 1 by 4 by R square. Time over. You can discuss on.